let's go through LeetCode 126. What a letter to. For this question, it gives us a begin word, end word, and a word list as dictionary. And for every operation, we can change one character from a word to another character. And if the other word exists on the word list, then we can have one operation here. We're trying to find the path from beginning word to the end word, and the path will have the shortest sequence. That means from begin word to end word, the operation times will be the minimum. For word letter 1, the shortest, we just return the shortest operations, the steps. And for word letter 2, we need to find the path, right? So intuitively, what we think about is that we just use the word letter 1, find the minimal steps, and then do the DFS from the beginning to the end word, and have the steps as one of the limitations to cut branches. Then if we, for example, add the step word, the word equals the end word, then we add the path to the result. Let's say for this kind of method, originally it can pass, but now this question has been changed to be more stricter, and that kind of solution will exceed the time limitations. So we need to have better approaches. Like word letter 1, right? We can do 2 optimizations. One is that instead iterate every word to see if that word has one character differences. We just change every character in the word, trying to see whether the dictionary contains the next. Another one is that we compose the get next during the BFS instead of compose the graph at the beginning, because the word dictionary will shrink. So let's begin to write word. First thing we need to make sure is that we need to compose, trying to see whether the word list contains the end word. So we'll have list string result equals new array list, and we'll have dictionary set string dictionary equals new hash set word list. Let's say if this dictionary doesn't contain any word, we just return. We just return result. Okay. Next step is that we are going to do the BFS. So this will be the key part. We want to pass the do not have the time limitation exceeded or memory limitation exceeded. So we know for this BFS, what we do is that during the BFS, we can compose a graph. That is the path, right? String list string. Let's say graph equals new action. We want to find compose this, and let's have a dictionary at the begin word. Okay. And we want to do the BFS. We need to have a graph as a parameter into it, right? Because we want to compose this. We can have the begin word, end word, and also the dictionary as parameters, right? So we'll have dictionary as one of the parameters. So we need to have the begin word, end word. Here, we want to compose the graph during the BFS, because if we reach the for example, from starting point, if we find the target, right, then this kind of graph, for example, we have a string and its neighbors, we can put on the list of the string. That will compose the path of the graph. Here is some kind of tricky things to do this kind of BFS. We want to compose this graph. There are two kind of scenarios that we compose from the start word to the end word, right? In this case, for every graph, every key, it may have multiple child. It will be some kind of expanding graph. So if it is like this, when we do DFS, those kind of branches is getting bigger and bigger. So we're thinking about in another way, whether we can compose a graph from the end word to start word. That is we doing like such, like the reversed direction, right? And we'll see for its next. I'll say this is next, and this current, and we'll have the next is going to current. Okay. So we compose a graph from next to current. In this case, this kind of tree will be kind of shrink, or this kind of shape, right? It's not like expanding. In that case, that DFS, we can pass that. That will be the key point for this question. And also, we think about this way. If we do the BFS from the end to the start, that is the same as, for example, from a node word, okay, node 3, okay. That means we have a minimum 3 steps to the end. And we do a DFS if we find node 3, and we only left 2 steps. In that case, those kind of branch we can cut off, right? So this is the equivalent. That means we don't have enough steps to go to the end. The minimum steps, for example, it will be 3 steps. But if we have a branch, it already goes to, for example, we have the minimum step to be 5. Okay, we already goes to in a route past 4 steps, and only have 1 step left. But not go to this node, right? But this node we will have at least 2 steps. So this kind of branch we can cut off. So this is the same thing we do. This will be the thing we trying to do the BFS from the reversed direction, from the end word to the begin word. Okay. And in this case, we'll have this will be next. Okay. next will be the key, and the current will be one of the value in this list. It's not necessarily one-to-one because for example, this current, it can go to this next, right? And another current, it can also go to this next. So this next, this chart will be have this and this, okay? But the good thing is that doing this way, we have reversed the direction to the BFS. It will be shrinking, and our BFS will not have the time exceeded issue. And also because like the word letter one, our dictionary, we are going to remove element from it. Actually, we have begin word here. It is fine that if we reach the begin word, and for this layer, after we finish the A-1, this layer BFS iteration, we can terminate. But the thing is that because this dictionary is shrinking, right? So we don't even need to pass the begin word because eventually the things in the queue will be empty. So we can just have the end word into it, okay? So let's begin to write the BFS function, okay? All right, what BFS? We are going to have a set string dictionary, and we are going to have a string. We'll call it any word or word, doesn't matter, word. And we are going to compose this, right? Compose this. This is our target. Okay? Here is the thing: is that during the BFS, for every layer, we want to remove those kind of things from dictionary. So that the next layer, that this kind of dictionary will shrink, like the word one. But we can improve this a little better. I will talk this bit later. That is, we have a red queue first. First new array that. And we're going to have a queue that offer this word. I'll say we have a variety that string variety because new hash
unknown color.
And we have a variety add this word. Let's say this while this queue is not empty. We have as we mentioned, we have a list, right? List of string list equals new array list. We have int size equals queue size, and we have for int I equals 0 I smaller than size I plus plus, and string parent equals q dot put. That's right. And after this for loop, we'll do for string tr in list. So if this dictionary contains this star, right? We'll have this dictionary remove this star. So let's say for string next, we'll have get next, current, dictionary, if visited contains next, we are going to continue. We'll have visited add next, and we'll queue offer next, right? So this will be our queue. And the things that we want to compose this map, right? So we have next and current. Current is here, next is here, right? But we do DFS is in a reverse direction. So we'll have this graph compute if absent. Next, A goes to new array list, okay, and add count, right? So for this question, we can have another way. Instead of to save the memory usage, because we can add, for example, pull everything. When we pull from the list, we'll add this one, add a current, right? But this way, it may have the memory. Sometimes it will pass, sometimes it will have memory exceeded issues. So we can put a less element in the queue. Is that for every next, we have list add next. Yeah. And in this case, we have dictionary to remove the first one, word. So this was our BFS. Like in the word letter 1, we need to write the get next function. Let's have this private list of string get next. Okay. So we have string word, and we have a set of string as dictionary, right? So we'll have list of string result post new array list return result. So we change this one array equals word to array for int I equals 0, I smaller than array dot length I plus plus, and we have char ch equals array I, right? And we'll have change this one for char c equals to a c small equal to z, right? And c plus plus, and we'll have equals c equals ch. We are going to continue, okay? And we'll have array I equals c. And after this follow, we'll recover this one to be ch, right? And here we have a string str equals new string array. Let's say for this kind of dictionary contains string, we'll add this one to the result. Result add +3. Okay. So this will be our get next. So after this, we will get the graph. Of course, we can during the BFS we can have two graphs. One will be the forward direction graph, which will get return the minimal steps go to that kind of node. But because this is expanding, it will still have the time exceeding issue. It will improve a little bit because when we do DFS, if this kind of node is already more than the minimum step, that means the kind of route is not economic. But we do the reverse BFS way like this, because this is shrinking, right? So then we do the DFS here. This will be the key point to have this kind of question past that time limitation. So then we do DFS. We'll have a path, right? List of string path equals new array list. And we'll have this path at begin word, okay? And we'll have DFS graph, right? And we're going to have current word will be begin word. And we'll have target word, that will be the end word. And we are going to have the path and the result. And we're going to return result. So this kind of DFS will be kind of dribble, private wide DFS. This is what we composed. And we are going to have string current word, right? Current. Now we're going to have a string target. And we're going to have a list of string as a path. And we're going to have a list string as result. Okay. So we'll say if current equals target, we just have result at when you have deep copy a new array list as we cannot return here because we have multiple roots, right? So we need to continue, just cannot have a return here. Someone may have the use a BFS to have the minimal steps, and write if current equal target, and the path size equal to minimal size, minimal steps, then add. And if the step the path is greater than minimal steps, then trim. That is okay. But the thing is that for this BFS, it's already granted that the path will be the optimal. So someone return steps here and have that this one as a minimal steps as a trim condition. But if you add this parameter, it is fine, but not improve too much. So let's say if this map does not contain this key, we can return, right? We don't this DFS finish for this graph. Doesn't contains key current, we doesn't need to return, right? And then for every next for string next in graph get, right? We are going to have pass add next pass remove has stock size -1, right? And we are going to have a BFS graph. This will be next target as result. Okay. So this will be our solution. Trying to see. Yeah. Trying to see this one. Heat cog. And submit. Of course, this one you can in order that you have better time ranking, you can also add a forward map, right? During the BFS, you can have a forward map. And during the DFS, if those kind of find are next, right? And this next, these steps, the size is already greater than the forward map. We can trim that. We can add some logic here, but that does not improve too much. And also, you can have a maximal steps. If those kind of steps already exceed the maximal steps, you can also trim. And also during the BFS, you can have a start word here, right? If you already find the start word, for this kind of for loop, you just need to finish this kind of for loop. If you find a start word, you say, for example, have Boolean find if find this start word, then return, right? That way can also improve the time. And also someone use a bidirectional BFS, use two set and as a forward set and a backward set to exchange the set and a time set. But I don't like those kind of way, because it is more like writing in template. And also you need don't want like remember too many templates. So doing like this way, we have BFS. The key point is that we BFS from the target, right? So that we search DFS. Well, this part will be trimmed. This part will be trimmed. So this will be the key point. And also some optimization part is getting next, right? During the BFS, this kind of set, we can shrink it. Of course, I tried that. I composed the graph at the beginning here, and do not do it at in the BFS. It will still pass, but the time is not that good. So the key point is BFS from the reverse direction. That will be the key point. And also we can remove here, right? In the order letter 1, I add here, right? Add every current and remove for everything in a layer. But for order layer 2, we add here, so that it will have minimal things in the queue. Will not have any memory issues. Some other things like a get word, that is we change every character instead of iterate the dictionary, right?